This is an introduction to the iterated integral. An iterated integral is treated similarly to a partial derivative. Essentially, we're going to be integrating with respect to one variable at the time while holding the others constant. So this double integral notation here basically means that we're going to look at this innermost integrand first and integrate a surface function, a function that depends on x and y, but first regarding only y as the variable and treating the x value as a constant. These inside limits would be treated as y limits and plugged in for the y values once I have calculated that antiderivative. When this has been entirely completed, we'll have another function that can then be integrated, but this time with respect to x. So when we see this iterated integral notation, it means that we integrate the surface function first with respect to y, and then second with respect to x. So let's take a look at an example. And we're going to grab up this first inside integral. The integrand is 1 plus 8xy, and remember that's basically the surface function or the ceiling function. And we're going to integrate this first with respect to y, which means that we're going to be holding all x values constant. So the integral of 1 with respect to y is just y. The integral of 8xy with respect to y, the 8x is a constant multiple, and then we'll integrate y. That's going to be y squared divided by 2. Let's clean this up just a tad bit. And then we'll apply our limits of integration from 1 to 2, but these limits here are going to be y limits, meaning that we plug them in for only the y values. So now we apply those limits. 2 goes in for y plus. For x, nothing goes in for that x. 2 goes in for the y that is then squared. And then from that, we're going to subtract, plugging the lower limit in, 1 in for y. Again, nothing goes in for the x. And when we simplify this, we get 1 plus 12x. So now we'll essentially substitute that 1 plus 12x in for that inside integral and then use that as the integrand for the outside iteration, which is then integrated with respect to x. Notice with this outside iteration, there are no y values anymore. We've plugged in y limits for all those y values, so we shouldn't have any more y's in this outside iteration. So all we're dealing with are x's. The integral of 1 is going to be x plus 12x squared over 2. Then we simplify and evaluate from 0 to 3. So now plugging in our limits, and this final calculation turns out to be 57, which is the output value of this iterated integral.